All right. It is time for another exciting Labcast from the creative minds that brought you Lab. And then Cart Lab, but with acceleration. Now we have Cart Lab with acceleration and with forces. It's a Newton's second law lab, people. All right. Our good friend the cart is still here. Now we have, though, a new addition. This new addition is our dual range force sensor, showing here. You'll notice it has two settings, plus minus 10 newtons, plus minus 50 newtons. We're going to be pulling this, so plus minus 10 newtons of force is going to be good for us. I've got this now clamped onto this little peg on top of my cart, so I can pull it, and it's measuring the force applied to this hook, as I can get a pulling force or a pushing force. That's why I can get this plus minus 10 newtons. And so this is important because you can hear clicking away over there our good friend the motion detector, which, because we're playing with carts, I've set to the cart setting. Our goal is to investigate Newton's second law. And to do that, we're going to need to measure the force that we apply to this cart and the acceleration of this cart. And so that's what we're going to get off of our lab quest here. You can see in channel 1 I've got a force sensor plugged in over here on the side. I want to zero this, of course. In channel Digisonic 1 up here, I've got my position sensor, my motion sensor set up over there. This I don't actually have to zero if I don't want to, because it's only interested in my change in position to get towards my acceleration. But I can still zero it all the same. So what I'm going to do is grab this. I'm going to start moving it back and forth, keeping a good distance away from this, because if I get too close, it begins to freak out, and that's not good. And my goal is to apply a lot of different forces. If I apply a lot of different forces, I get a lot of different accelerations. And so I'm moving it back and forth and back and forth, and I'm going to collect my data. And it's collecting and collecting and collecting. Yay, data. And so what we can see here is that I'm moving it back and forth. I'm applying between, it looks like, plus minus 4 newtons of force or so. So I could go a little harder because I can go up to plus or minus 10. So that's good to keep in the back of your head. But now, if I'm interested in Newton's second law, I want to change what I'm graphing. Right now I'm graphing force versus time. So you can see I'm pushing forward, pulling back, forward, back, keeps going like that. But Newton's second law tells me instead about a relationship between force and acceleration. Remember, force is equal to mass times acceleration. Yes? Yes. Now, you might want to think, what are the forces that are acting on this? And particularly, what are the forces acting on it that relate to its acceleration horizontally? You may want to, at some point, draw a free body diagram. Hint, draw a free body diagram. But if I look, I'm going to graph now force versus, look at this, acceleration. Nope. Well, that's actually an exciting picture for force versus velocity, but that's not what I wanted to graph. That, if I put it far away and squint slightly, although if I squint the camera it doesn't squint, so that doesn't help, looks like a line. Right? Boom. If I were to, for example, put a curve fit for this and make it linear, it would actually be pretty reasonable. It's a pretty decent correlation there, 0.98. This slope has some physical significance. I'd leave it to you to think about what that significance is. Now, what you're going to want to do in this lab is two things. One is repeat this step here and get to this slope and figure out what exactly this slope is telling you and see if it's true or not. So you can get kind of a percent error analysis on that. The second thing you're going to have to do, I'm going to have a couple of mystery objects for you to put on your cart. And what you're going to need to do is figure out the mass of those mystery objects based on the data you can collect. You're going to have one of probably 4 objects, and I will know its mass, and you will not. So yes, it should be enough to get you started. Be ready to do this in class.